Hi, there are 4 speakers. Thank you for coming. The first, I'm going to skip the whole preamble because we're starting a little bit late because of the other event running a little bit late. The first speaker is Robert E. Novak. He works for Nexenta. He is the Director of Systems Architecture. I'm going to let each of the speakers give you a little bit about themselves. I'm going to try to rush them through their presentations just a bit so we finish more or less on time. If we finish a little bit late, I apologize. Robert, can you please start?
Sure. Okay, so this title is a bit innocuous, but I'm going to try and cover some stuff that, amazingly enough, there were press announcements just yesterday that tie into this talk. So we'll get to that in a moment. So, what are some components of software-defined storage? Of course, portability, ubiquity, agnostic, not cast in iron or silicon, and making tiering of storage invisible. So these are all properties of software-defined storage, but you also have to have management pieces that apply both to software-defined storage and software-defined networking. In other words, your policy has to scale out to all the servers. You have to have distributed robustness. Single points of failure are not the end of the world. You have to have centralized administration and security, simple disaster recovery, and lower the CapEx and OpEx costs. If you don't do that, you're not in business. Nobody'd buy it anyway. So, this is a brief look at how storage has been evolving over time. We started out with on-premise storage, went to multi-premise, and we'll get through these other acronyms as we get through that. Most companies have been at this stage, either on-premise storage or multi-premise storage. We're just starting to see cloud invading that. So you started out with one rack in your data center, stuffed it inside your factory or your physical plant, and then you kept growing and adding more and more servers over time till they kept growing to the point where you had filled up your entire facility. So then you built another facility. Now you're at multi-premise storage, and you've got to link all those together. Now, you find that instead of having just those multiple locations, you want to put the stuff out into the cloud. So you add a cloud to your environment so that you can access the data remotely instead of keeping it all on site. Then your multi-premises all have to be linked together and linked back to the cloud. But this causes a little problem because now cloud's changed. Cloud is now object, not your classic files that you always dealt with. So these are my representations of objects because I didn't know what else to put down for amorphous blobs, but amorphous blobs.
Yeah, I have the same problem, actually.
So then you have this little problem where one site gets wiped out by a flood or a hurricane or a tornado, and you wind up having to put a gateway in because you have to do something that's called rehydration. Because now your remote server personnel or your remote client personnel that can no longer sit at their factory because it was wiped out by the hurricane or flood are now sitting at home or rented facilities using laptops, and they all have to connect directly to the cloud individually. But that means that they had to go through this hydration server, because one of the aspects of cloud storage or object storage is that it takes your very rich metadata hierarchical file structure and puts it into a very flat and wide object space. And you have to rehydrate that every time you access the data. And this is a real pain. You then wind up doing some more things over time, so that you wind up putting a piece of the cloud in your own factory or your own premises, and you have your hydration locally instead of remotely. We think that there's a fundamental change in the way storage has to be thought about. This is a model that we originally put together in describing Hadoop-type models, where we broke all the paradigms of Hadoop. we said, no, you're not going to move compute next to the storage, because storage servers and compute servers have two different paradigms. And in fact, compute servers evolve very rapidly and change all the time as CPU speeds go up, number of cores go up. You can't stuff 40 disk drives into a 1U flapjack type of server. So we think that because of the fact that we have fast Ethernet, that you can now access all that data across the network. In fact, SAS is too damn slow. All right? SAS is not the way you want to get at your data anymore. You want to get at your data over the network. A proof point of this was just in yesterday's news. Seagate announced a brand new type of drive, a key value drive. We'll talk about that more in a few moments. But the key thing about that drive, pardon the pun, is that it's TCP/IP access, not a SAS drive. And that's very timely. I didn't know they were going to make the announcement just prior to this talk, but that was great.
That was for you.
Yeah, just for me. So we see legacy storage is getting squeezed from a couple different fronts. First is your BYODs, your tablets, your phones, access storage in a fundamentally different way than your laptop or your desktop machines. You don't think about opening, reading, updating, writing, closing files. You just get and put files with these new devices. The same thing's true of NoSQL databases. They don't think of transactional things in the same way that traditional storage was set up to handle it. And of course, all your S3 object-compatible applications that use S3-style APIs behave very differently with just get and put. Now, the real trick is there have been two announcements from Seagate just in the last 60 days. One is SMR drives, shingled magnetic recording. We'll show a diagram of that in a few moments. They announced that about a month ago, and those drives, they claim they've shipped already 1 million drives, none of them for enterprise customers, only for consumer customers, because they haven't solved some of the performance challenges of SMR drives in the enterprise space. We think we can show them how to do that, but we'll work on that a little later. Objects and files on top of block I/O are getting squeezed out because of these trends. All right? Objects and files on top of POSIX libraries or POSIX models are also getting squeezed out by these trends. We think the solution is going to be objects that are copy on write and distributed using POSIX emulation. I can't talk about some of the rest of that stuff behind that statement. That's all NDA. Coming soon to a theater near you. So here's some aspects of the devices. Your traditional drive, this is a very crude graphic that shows that you've got your white blocks of data separated by large gaps between the blocks of data in order to prevent hysteresis of the magnetic recording from wiping out the adjacent block. That leaves huge gaps, doesn't use your density very well. But it does let you randomly read and write the data. Shingled magnetic recording does overlapping writes similar to the shingles on your roof. You lay down track 1, and then track 2 lays down right on top of it. And the reason it can do this is there's a lot of hysteresis in the magnetic write of the track. But the read head only needs a very narrow zone to do the reading. So when you lay down track 2, it overlaps most of track 1 so that that's no longer available. And similarly, when you lay down track 3, it overlaps again. So this way, you have squeezed much more data onto a drive. You get better areal density. The areal density improvement, somewhere between 25 and 60% improvement in your storage space, depending on how you organize all this. So one of the ways to organize all of this is, in fact, to group the shingles. I called them bands here. I guess the drive folks are actually calling them zones, into different separate zones, which are separated by the gray gaps there, so that you can copy from one band to another to do garbage collection. One of the nice things, or one of the nice properties about these drives, is that they can be organized so that the outer diameter blocks are still random I/O, as are the inner diameter blocks. That happens to map perfectly directly to ZFS Uber blocks, so that ZFS, which is a copy on write file system, can actually have no change in performance and use an SMR drive. And we're working with several companies now to make that happen and bring that to market. So we can hang a file on the file system through the Uber blocks with that random I/O, and we can copy zone to zone when we need to free up space to do your garbage collection. You have to do a two-step garbage collection. It's blocks to be freed, then you have to clean up the zone, and then put them on the freed list, the whole zone at one time. So we think it's going to be the dominant method of growing capacity over the next 3 years. You're going to see 10 terabyte drives coming, so that existing 4 terabyte drives with the same drive geometry and technology and different firmware could actually run to 10 terabytes. Next thing is key value storage. So I encourage you all to go take a look at Seagate's press announcement. It is groundbreaking in terms of a major player getting behind key value implementations, so that you're doing a simple API that looks remarkably similar to what you see with the Amazon S3 interface. You put data, you get data, and sometimes you delete data. That's actually a much rarer occurrence than people like to realize. And then you have to get all keys to have the drive tell you what keys it's actually storing. And sometimes you have to get them in chunks at a time. Seagate's announced doing it with TCP/IP. We think UDP might be a better method. So we've filed some patents around that on how we do UDP protocols. Fuse over Amazon is an illustration that you can take an S3 object storage and treat it with a POSIX-like library to do open, read, update, write, close operations against objects. And we have a way to do this implementation, which includes being able to do operations like seek within an object, or seek and update part of an object in a way that is invisible to the application. The application still has to be aware of some of the underlying changes about eventual consistency, because there's no locking mechanisms in the object paradigm. So that you have to be aware of the fact that someone may have come in and snuck in and done a change after you'd done your change. So you have to go and reread and reapply your changes. Now, we believe that therefore a good object store should not delete data, but should keep a history of old versions until you've reconciled all of those changes. So you don't march from object version 4 to object version 5 and wipe out all the version 4 copies. We believe it should keep those older copies for a longer period of time. Not much longer, but a little bit longer. I'm going to skip past that. So this is the other half of the way we think designs change. We think that the server is going to get rid of most of the PCI Express bus. You're not going to be using HBA controllers in the way you have in the past. You're still going to need some legacy devices, but you're basically going to put an Ethernet switch on the motherboard. And that Ethernet switch will be used to talk to other Ethernet switches, which are embedded inside of an Ethernet JBOD that holds Ethernet attached disk drives. Now, that's what Seagate just announced yesterday. So couldn't have been better. I was very happy they did that for me. So this means that now when your server motherboard dies, you haven't lost all that data, because a different server coming in on Ethernet can access those drives. A key part of the right protocol to do this means that you have to have ways to keep the data consistent and arbitrate between the servers without performing locking and without creating deadlock situations. We know how to do that. It's not that hard, but it's a little bit tricky, but we can manage that just fine. So this is going to change the way you think about servers and the way you think about storage. Storage is no longer associated with a server. Storage is available to any of the servers in your cluster. A drive is no longer just in one place or two places. When you had dual access, you attached the drive to two different servers. But now it's available to any of the servers in the network. So if your server fails, any other server can take over. So on-premise and multi-premise could work well with legacy storage silos, but they don't play well with others when it comes to storage in the cloud. This is not the strength of the legacy providers. They do provide legacy POSIX semantics, but you don't really want to care about that going forward. That's one of the shifts that's happening. Applications don't know and don't care about background archiving. You don't want to think about, I have to remember to trigger an update or an archive because I've just updated my data. Applications don't want to know about limits of storage. They believe in infinite storage. There are no boundaries as far as applications are concerned. And they thrive in open source environments with open APIs so that applications grow and change so that you get the huge explosion of applications that you see in the iOS space, in the Android space. You get all kinds of applications. So these open source APIs are going to drive the definition of software-defined storage by having future APIs that include REST as well as native language APIs. S3 APIs, we believe, are going to be the model for all the future storage APIs. It's not that we'll do exactly S3, but it's going to be the template for how we extend those. And then S3FS shows how both objects and files can coexist in the same environment. And object storage has to solve this dehydration, rehydration problem so that you don't lose all this rich metadata in the file system hierarchy. Making the POSIX evolution to PUTJIT. PUTJIT is put-get. It's a name so bad you'll never forget it. It's going to happen faster than we think because of the BYOD devices and because storage devices will have the key value for more cost-effective storage. The reason it's more cost-effective is that when you use key value as opposed to cylinder, track, and block, the drive can quietly reorganize your data on the drive to optimize fragmented files into coalescing into sequentially accessed files for faster performance, all in a way that's transparent to you. So those are going to provide a huge value add for improving your performance. But it's going to happen slower than we think. Legacy applications don't change. They don't get rewritten. And in fact, legacy applications don't die. My favorite example of this is in the City of London. The financial applications all depend on very old applications written in COBOL that convert the decimal pounds into pounds, shilling, pence, do the computations, and then convert them from pounds, shilling, pence back to decimal data. That's an application that's not going to die. Another classic example is our automated clearinghouse, also written in COBOL. It's the reason that it takes 3 days to transfer from one bank to another when they're right next door to each other in Manhattan. It's still a 3-day ACH clearing process. So those are the reasons why it's going to happen both faster than we think for some applications, but it's going to stick around for a long time for others. And that's it.